So now we'll be starting with activity 1.3. So here they've given a function which is from f of r to r. Okay, so defined as f of x is defined as x square plus 1. So which of the following option represents the graph of the function, right? So the graph of the function is always defined as, let's say, gamma of f, let's say, is given by all the points such that x comma f of x such that x belongs to r, right? So this is the standard form. So here instead of f of x we have to substitute what? We have to substitute x square plus 2. So the first option gives us the answer, right? Fairly simple. So we'll move on to the next question. So here let's see be a curve of the following in the following figure. Which of the following lines in the tangent is the tangent at some point to the curve C? Okay, so this is the question. So we have a curve and we also have three lines. So they are asking us which of the three lines represents a tangent for this curve, right? So what about this line? Let's go one by one. So here this line intersects this curve at 2 points, right? And also at any of the intersection point, this is not in the direction of the graph. Let's say this or this, let's say this graph, this is the direction of the graph, right? If you are moving from 0 minus infinity to plus infinity, right? So this would be the direction of the graph, but the line is horizontal, right? So this is making an angle, right, with the graph. Here also this line is making an angle with the graph. Okay, so the first option, that is the line 1, is not a tangent, right? So what about line 2? So here in the line 2 we have a single point of intersection. Also at this point the direction of the graph as well as the direction of the line is same, right? So we can say that line 2 is a tangent. So what about line 3? Line 3 does not even intersect or touch the curve C at any point. So the option 3 is also not right. So the correct option is line 2. This will be a tangent at this particular vertex of this parabola, right? Moving on, uh, let's see be a curve in the following figure. So okay, we have a curve and we have a line. So what are they asking us? They are asking us that L be a straight line which touches the curve at point according to the figure. Then L is the tangent to the curve at point. So they have given a line and they are asking us to find at which point this line is the tangent to this curve. So it is touching or intersecting the curve at 2 points, namely P and C. So what is happening at C? The curve direction is somewhere like this and the direction of the line is somewhere here. So it makes an angle. So if this makes an angle, so this is not a tangent, right? So what about P? In P the curve is moving like this here and it is moving like this here. So at point P exactly, so what is happening? So we have a somewhere here I have written an exaggerated figure. So let's say this is the point P. At point P the line is also moving here, so the direction of the graph as well as the line is same at point P, right? So point P is the point where L is a tangent to the curve C. Okay, so next question. Let's see be a curve and three straight lines L1, L2, L3 pass through the point P in the following figure. Okay, so we have a curve and we also have three lines 1, 2 and 3 which passes through the curve at P. So what are they asking? They are asking which of the following straight lines is the tangent to the curve. Again simple, we have to simply check the direction of the curve as well as the direction of the line. I'll write the exaggerated figure here. Let's say something like this. Okay, if this is the vertex, let's say this is the vertex P and we have one line going here, that is L, and we have another line here, let's say this is L2, and I have another line L3. Okay, so what about this L1 and P? So the direction of the curve as well as the direction of the line is horizontal, right? So this will be a tangent. What about L2? It makes an angle, so this is not a tangent. What about L3? Again, this is perpendicular, so this is also not a tangent. So the correct answer is L1. Okay, so next question, which of the following option represents the graph of a quadratic function? Again, I've told you that graph is represented by, gamma of f is represented by set of all points such that x comma f of x, such that x belongs to R, real numbers. Okay, so here we have x, so all the option has x in the first point as the first point. So what about the second point? So they're asking us a quadratic function. So in after the comma, which of the following option has a quadratic equation, right? So it has the first option has a degree of 3, so this is not a quadratic function, this is a cubic function. Okay, so second option we have degree 2, so this is a quadratic equation, so option 2 is the right answer. What about option 3? Option 3 we have degree 4, so this is not a quadratic function. So option 4, after the comma we have a linear equation, so again this is also a not quadratic function, so option 2 is the right answer. Next question, let f of f tends from a to b be a function where a and b are the subsets of R and the cardinalities of a and b are 4 and 1 respectively. What is the cardinality of graph of f of x? See, they're asking us, we have function a subset a, and we also have a subset b. In subset a we have 4 different elements, right, or 4 different numbers. Let's say, since this is a subset of R, let's say a has 4 different numbers. And what is the cardinality of b? The cardinality of b is 1, so it has only one number. So there is a function which maps every value in a to a single value in b. All these points are mapped to a single point, let's say, so that what will happen to the graph? So the graph of f will be such that it has all the points of x comma f of x, right? So what about x here? X will be taken from this thing, from a, and what about f of x? F of x is taken from b. So this, let's say if I am naming this as a1, a2, a3 and a4, and this point as, let's say, b. So what will be the number of points? We'll have a1 comma b, I'll have a2 comma b, I'll have a3 comma b, I'll have a4 comma b. So total number of points in graph is the cardinality of graph, that is the total number of points. So this is nothing but 4. Okay, moving on to the next question. Okay, so let's see, represent a curve in the figure. Answer question 7 and 8 using the curve. Okay, so we have a curve something like this. So they have given us all the points where the curve changes its direction, right? Okay, so now what about this? Which of the following points, which of the following options are true? So this is the question. So what about the first option? The first option says at point P there is a tangent. So let's see, at point P, is there a tangent? Can we draw a tangent at P? So let's say we have something like this. So they've given a tangent, right? So they're talking about one unique tangent, right? So what will happen? So can we draw a single tangent here? Right? So we cannot draw a single tangent at a point of where the graph changes its direction from increasing to decreasing, right? so there is no tangent at point P. Okay, what is happening at point Q? So at point Q there is no tangent. Yes, so this option is correct. Again, I've told you that even if the graph, if the curve is changing its direction, at the point where it changes its direction we cannot draw any tangent. So again, so this option is true. At point P there are infinite number of tangents, so this is again false. Why? Because we cannot draw any tangent here. Why? Because this function is different and this will be sorry, not function, the nature of the curve from the left side as well as in from the right side will be different, so we cannot draw any tangent at this point. Okay. Since option 2 is right, we cannot choose option 4. Alright, so we also have, let A be the set of points where the curve has no tangents. Find the lower bound for the cardinality of set A. Okay. So for the given graph, for all the points where the graph changes its direction, so that is P, Q, R and S, we cannot draw any graphs. So what about T? At T the graph is not changing in its direction, right? So we can draw a tangent, so the tangent will be coinciding with the graph, something like this. Okay, so the lower bound of the cardinality means if we continue this graph, let's say if this graph is continued, we can have n number of points, right? But they are not asking us to find out all these points. They are asking us to find out the lower bound, the minimum number of points as they have shown, right? So that is nothing but P, Q, R and S, that is nothing but 4.